Welcome and thank you for joining me in this lesson. Today we will learn about the cross product. Remember that to find the product of two things, for example, two numbers, means to multiply the two numbers together. And the way that we describe this is 2, and then we write a dot in between 3, or we can also write it sometimes as 2 times 3 with this little cross. Now, since there are two forms of vector multiplication, we're going to use these two symbols that practically mean the same thing or describe the same mathematical operation, which is multiplication, in order to identify the two types of vector products. Now, we already saw the first product, which we, by the way, call the dot product, because we use the dot in between. And we found out that the dot product of two vectors is a scalar or a number. So we can call it either dot or a scalar product. Now, in this form of multiplication, we learned that if we have two vectors, say for example A and B, where the coordinates of vector A are x at A, y, A, z, A, and vector B, x, B, y, B, and z, B, then the dot product AB was found by simply multiplying the x coordinates, multiplying the y coordinates, and the z coordinates, respectively, and then adding all the products together. So, in other words, we had XA, XB, plus YA, YB, and then plus ZA, ZB. Now, cross product, unlike dot product, will give a vector. This is the reason why we often refer to cross product as the vector product. Now, let's take a look about some of the most important definitions of cross product. So, it's denoted by the cross, A cross B, generates another vector, and the vector it generates is perpendicular to both vectors A and B that are multiplying. What does that mean? If you place any two vectors in 3D and you bring them to their position vector, position, which is with the tail at 0, 0, then the two vectors will connect at the tail and will make a plane. The vector that we obtain as a product of A cross B or B cross A will always be perpendicular to the plane created by vectors A and B, or in other words, it will be perpendicular to vector A and perpendicular to vector B. The magnitude of the cross product is very similar to dot product, but unlike in dot product, here we have sine theta. So magnitude is A, B sine theta. Now, since the direction of the cross product is perpendicular to both vectors A and B, then we'll say that the cross product is a vector, and that's how you would describe it with no magnitude, no absolute value, equals AB sine theta, and then we multiply by unit vector n. Now, unit vector n in mathematics will represent the normal to a vector or a normal to a plane. And normal means perpendicular. Cross product is very often used to calculate the area of a parallelogram formed by two vectors, because the magnitude of the cross product would equal the area of the parallelogram. And here we're coming down to the formula of how we calculate or evaluate the cross product of two vectors, which is very complicated when you look at it as a formula, but it's so fun and interesting to learn it practically. So let's take a look at a couple of examples. And we're going to look at the properties of cross product once we know how to perform it. So we're given the magnitudes of two vectors, vectors u and v. Magnitude of u is 3 units and magnitude of v is 5 units. The angle made between the two vectors is 45 degrees. We're asked to find the magnitude of their cross product. To find the magnitude of their cross product means that we're trying to find the absolute value, u cross v, which equals magnitude of u, magnitude of v, multiplied by the sine of angle between them, which for now we'll call theta. Then we substitute u by 3, v by 5, sine theta by sine 45, and then we'll say that the cross product u cross v equals 15 root 2 over 2. That would be the exact value. And if you want to find the approximate value of it, then just simply use the calculator and we'll get 15 divided by 2, which is 7.5, square root of 2, and then the answer is 10.6. So we're going to say that the magnitude of this cross product is 10.6. Now let's move on to the next example. So we have two vectors, A and B, and we're cross producting them. So step number 1, we're going to write the unit vectors I, J, and K aligned. And we'll repeat that one more time. Because we're multiplying A cross V means that vector A comes first. So we'll go vector A with coordinates 1, 1, 0. So the coordinates are listed right below each axis. And then in the same way, we'll repeat vector A one more time, 1, 1, 0. For vector B, we have 1, 3, negative 1. So here goes vector B, 1, 3, negative 1. And we'll write it one more time, 1, 3, negative 1. Now, it is very important how we align all the coordinates. We must list the coordinates twice in the horizontal direction for each vector, and we always start with the first vector in the cross product. So now we're going to start with crossing the vectors or the coordinates. So we go with the down products. So we're going to start from the left side, which is the I component, and then continue with J, and we always go diagonally. Now we call these the down products because if you follow this product left to right, just like you read a book, then your pen will go down. So we're going to multiply I by 1 by negative 1, and that will give negative 1I. Obviously, it's okay to write as negative I. Next, we have J, 0, and 1. That would be plus 0J. Next, we have K times 1 times 3. That would be 3K. Now, remember that cross product will be the down minus the up product. So where are the up products? Just like we created the down products, we'll create the down product, the up products, and we're going to start off here with the component K, and then J, and then I. I prefer that I start from the very side of it, but you can start right away from here. It always comes with practice, obviously. And let me make this. Okay. Now, we are going to subtract the pink products. So we're going to obviously start with I, just to keep things in order. So that would be 3 times 0 times I is 0I. And then we have negative 1 times j. We have negative 1j. 1 times 1 times k is 1k. So all we have in here is the down product, subtract the up products. So let's simplify now. Remember that the vectors that go in the same direction can be simplified by treating them just like normal polynomial terms. So we have negative I plus 0j, so we don't have to write that, plus 3k, remove the brackets, minus 0I means nothing to subtract, then minus 1, negative 1j, that would be plus j, and then minus 1k will be minus k. So that would equal negative I, 3k minus 1k would be 2k. So we can save this for later, and then plus j, because we want to write them in order. As you can see here, the cross product A cross B gave us the vector negative I, j, 2k. So if you want to write this cross product vector A cross B, in standard form, then you will say that this would be negative I, comma, j, comma, 2k. If you want to write this cross product vector again, but in component form, you simply write the values of the magnitudes of each of each component. So negative 1, 1, and 2. So this will be the standard, and this will be the component form of it. Now let's take a look at another example. And again, I encourage you to try this on your own if you understood how we did the first cross product. So we have two vectors here, vectors p and q. And we have to find p dot q and q dot p. So just to refresh the memory so that we establish a good understanding about the difference between dot and cross product. Again, we're going to do cross product both ways, p dot q and q dot p. And let's see what we will obtain. So p dot q means that we have negative 1, comma 3, comma 2, dotting 2, comma negative 5, and then 6. So that would equal, so again, we're multiplying the x's, and then the y's, and then the z's together. So we have negative 1 times 2, plus 3 times negative 5, and then plus 2 times 6. So that would be negative 2 minus 15 plus 12, which equals negative 5. Now, let's continue with q dot p. So that means we have 2, comma negative 5, comma 6, dot negative 1, 3, 2. So again, same idea. We're going to go ahead and multiply the x's together, the y's together, and the z's together. Let's see. So we have 2 times negative 1 plus negative 5 times 3 plus 6 times 2. As you can see here, we got the same products, right? But they're just switched around, which doesn't change the value of it. So the answer, again, will be negative 2, negative 15 plus 12, which is negative 5. So in dot product, the order in multiplication does not matter. So in other words, we say that p dot q equals q dot p. So we're going to use the same vectors now to find the cross product, and we'll compare if p cross q and q cross p will give the same number. So we'll start with p cross q first. So what we have in this case is negative 1, 3, 2. So I'm going to start off by writing the vectors first, ijk, ijk. And then we have negative 1, 3, and 2 for vector p. So negative 1, 3, and 2, negative 1, 3, and 2. Now, vector q is 2, negative 5, 6. So 2, negative 5, 6, 2, negative 5, 6. I'm going to draw a line in here, and then I'm going to start highlighting the down and up products. I'm going to go down first. Oops, that was a little bit too big. So let's change it up. So we have the i's together, the j's together, and then the k's together. It is very important, again, how we align them. If you have grade paper, use a grade paper just so that we know we're going in the right directions there. So here we are. We have 6 times 3, 18i. We have 2 times 2j. And then we have negative 1 times negative 5 plus 5k. And then this would be, we said, the down product. Let's subtract the up products. So the up products are right here, k's, the j's, and the i's. So we're going to say negative 5 times 2, negative 10i. 6 times negative 1, negative 6j. And 2 times 3, k. So plus 6k. 2 times 3 is 6. So these will represent the up product. So the down products added together, subtracted by the up products. So the up products are going this way. So let's simplify now. We have 18i plus 4j plus 5k plus 10i plus 6j minus 6k. So 18i plus 10i, 28i. And then we have 6j and 4j together, 10j. And last, 5k minus 6k minus k. So this will represent the dot product. We call them P cross, the cross product, P cross Q. So let's continue with Q cross P now. So again, same drill. So you go I, J, K, I, J, K. And the more often you do it, the faster you can do this as well. So remember that this time we're starting with vector Q. So the second vector. So we'll go 2, -5, 6. 2, -5, 6. And then we go -1, 3, 2. -1, 3, 2. That would be our vector P. -1, 3, 2. I like to draw the line in here. And now I'll continue with the products. So let's go down products first. And then we go the up products. So also, again, remember that these are the up products and these are the down products. So we have I -5 times 2, -10i. J6 -1 minus 6j. K2 and 3 is 6k. And now we're going to go up 3 times 6 times I, 18i. And then we have 2 times 2 times j, 4j. And then we have -1, -5k is positive 5k. So let's take a look again. So we have the down product minus the up product. So we have -10i minus 6j plus 6k minus 18i minus 4j minus 5k. So the i's will go together to make -18i. The j's will go together to give -10j. And 6k here and -5k here will give 1k. So this would be the the cross product, Q cross P. I keep saying dot product, but I mean cross product. So let's compare now. Oops, sorry. So let's compare P cross Q with Q cross P. So for P cross Q, 28 for X and -28 in here for -18, -10, -28, -28 for Q cross P. 10, -10, -1, +1. So the coordinates are exact same, but opposite in sign. So exact same value, then opposite in sign. So we're going to say that P cross Q equals negative Q cross P. Now, let's take a look at their magnitudes. So for P cross Q, obviously we are going to use the coordinates of P cross Q, which are, I'm going to grab them here actually. So these would be the coordinates of P cross Q. And we'll say that the magnitude of it would equal the square root of the x coordinate, which is 28 squared, plus 10 squared, plus -1 squared. So use the calculator, I think is a big number, 800 something. Let's take a look. And we have 885. That's square root of 885. Now, similarly, we can find Q cross P, which has the coordinates negative 28I, negative 10J, and plus 1K by using the same formula for the magnitude. Square root of negative 28 squared plus negative 10 squared plus 1 squared. And that would equal, again, just use a calculator, root 885 units. Okay, so I hope this made sense, and I hope that you found learning about cross product, how to perform cross product easy. And I will continue the video with another example. Bye for now.